morning, good afternoon, and good evening, everyone. Welcome to today's webinar, where we will be discussing the Tolly Group test report of Cambium Networks Wi-Fi 6 access points. Today we have Kevin Tolly, the founder of the Tolly Group, and Bruce Miller, the VP of Enterprise Marketing at Cambium Networks, with us today. And just a quick reminder to everyone that if you have any questions at all throughout the presentation, to please go ahead and ask them in the questions tab on the control panel. You can also view the handouts from today's presentation in the handouts tab. But without further ado, I will go ahead and pass it over to you, Kevin and Bruce.
Okay, thanks, Riley. This is Kevin. Thanks for joining us today. Let me tell you a little bit about the background of our test first. Is that slide going to build out, Bruce? There we go. So topic today, of course, is Wi-Fi 6, and we've had Wi-Fi for a while, 1 through 5. Wi-Fi 6 is big, though, right? It's the biggest change in probably about a decade. It's big for performance reasons. It's big for density reasons. We'll explore some of that today, and we'll talk about what the ramifications are. And it's certainly nice that the Wi-Fi community has switched to nice and easy terms like 5 and 6 instead of 802.11, this and that we've had to deal with for all those years. So that's good. So, and Bruce, feel free to jump in along the way with any of your comments. So today we're looking at two different parts of the performance puzzle. We're looking at the 8x8, 4x4 high performance access points, and then the 2x2 general purpose access points, right? Because in most environments, you're going to want to have some distribution of both. So we're looking at both of those. And I'll go into some more details on the coming slides, but our test goals today are very straightforward. We're going to benchmark performance. We've talked about the fact that the performance with Wi-Fi 6 is very significant. Key point to look at here too that we'll explore is that for the first time, we're looking at APs that can kind of break the 1 gigabit barrier. So the uplink becomes much more important than it was in all the time past. So we'll look at that. So we're looking at the performance. We're going to look at it in a focused kind of drag race way in a few minutes. And then we're going to look at it in a more realistic way in a high density test. And then also important is we'll take a look at the pricing. So we'll give you some very straightforward TCO calculations that we did, as well as some price performance on the different solutions. Hey, Bruce, we've known each other a long time, going back from Xeris. Maybe now's a good time for you to give that a little context, the Xeris and Cambium technology together.
Sure. Yeah, and a good point there, because we call out Cambium Xeris here on this slide. Xeris was acquired by Cambium in August of 2019. And so the products that we're actually testing were a combination of the technology of the two companies. We established a new Wi-Fi 6 platform, released that last year, and had done a lot of testing in the lab. We'll get a little bit more into what we do from the testing side, and saw some very good results, which resulted in the engagement here with Kevin and the Tolly Group that resulted in this report. We did look to, obviously look at the performance and some of the things that might be obvious with Wi-Fi 6, but I did want to point out that we tried to take that to the next level and talk about density and latency and some of those things that are important when it comes to deploying Wi-Fi 6 in real world environments and some of the types of things that you may be deploying into today and some of the use cases. So that was kind of the overall goal. But I think it was very interesting results, and I think we'll dig into it here next.
Okay, sure. So next slide. So again, the first test is maximum throughput. This is what you'd expect. This is focusing on the AP with a small number of clients and just seeing how much data we can move through that AP bidirectionally, downstream only, and upstream only. Again, we do that profiling because different types of implementations are going to have different types of requirements. So it's good to see all three numbers. And then, as Bruce said, the high density real world, which we'll get into some more in a few minutes, is also important. So for that, we did, and you'll see a picture of it, a very impressive picture of the Cambium lab in a few minutes, a test that involved 100 clients on the 8x8 APs and 50 clients for the 2x2. And you'll see there as well that we look not just at raw throughput, but knowing that other latency sensitive applications, VoIP being the main one, are in the mix. That we also look at measurements of voice quality, very important, and latency and jitter, which are very, very tightly kind of connected with the voice quality. And then finally, we looked at the TCO price performance. And again, trying to keep things very simple. Right? If you keep things simple and you get some good results, that tells you a lot. So we'll have a 5-year TCO that we'll look at based on list prices and cloud support. And then we'll take the results that we'll talk about in a few minutes in terms of performance. And again, do some simple calculations that'll tell you, combining the performance that you're getting with the cost of APs, what's your price performance? What's it costing me per megabit per second of throughput? So we'll look at that. Okay, let's move on. So making the test real world is a big part of it, right? Why? Because you want to make sure that the APs, the behavior, the performance that we're seeing in our test will be modeled into a situation that'll work well for your environment, because you're in the real world. So what do you have out there? Wi-Fi 6 is the new thing, but there's still a lot of Wi-Fi 5 clients out there, probably today, and maybe Bruce can comment on this, predominantly. It's going to take a while for the devices to catch up. There's a combination of Windows, there's a combination of Apple, iOS, laptops, and tablets. So there's lots of different things out there that you have to be able to handle and handle simultaneously. Bruce, any comments on the client mix or Wi-Fi 5 versus Wi-Fi 6?
Yeah, I think one thing that we've seen from talking to a lot of customers is that there's actually more Wi-Fi 6 out there than people might think. You know, the last couple of generations of iPhones, for example, a lot of the new clients, if you're buying them, are Wi-Fi 6 by default. But then obviously there's a lot of existing clients and legacy clients out there. So I don't know the exact mix offhand, but I think we do find that when we're talking to customers that they may have more Wi-Fi 6 than they think, and Wi-Fi 6 infrastructure access points can obviously develop and deliver a greater performance when they're running with Wi-Fi 6 clients. But we also did some testing that showed benefits running with the older clients as well. So the infrastructure upgrade will boost performance of the existing clients that you might have, just based on greater sensitivity and some of the advances that have happened with Wi-Fi 6 over time. And then you get even better performance when you obviously upgrade your clients as well. So that mix was important to look at, and we thought through that carefully when we set up some of these tests, and we can talk a bit more about that as we go through them.
Sure, and to your point on Wi-Fi 6, while it wasn't part of our particular test here, I understand that the Wi-Fi 6 is also better in terms of battery efficiency, which I think is driving a lot of the handheld vendors to want to move more quickly, because everybody wants more battery life. So I think you're right there that we're going to see it probably be into our environments faster than we might normally expect. Okay. So in the high density, looking at this, again, 100 clients, 50 clients. We've got a photo coming up in a minute, so I'll hold off on that. Let's look at the traffic for this. So real-time traffic. So this is a mixture. So with the 100 clients, we had, I think it was like 80% doing throughput, so putting pressure on the access point, and the remaining 20% doing voice. We're using the Keysight Ixia iX Chariot test tool, which is a very well-established test tool company, and test tool that's used in a lot of our tests to give us empirical measurements of voice quality and throughput. So that's really, really important. So we have that, and you'll see that we have both the combination of throughput and voice quality. So you can see how both elements of your performance are going to be impacted in your network and what you can expect. And as I pointed out a few minutes earlier, multi-gig E uplinks. Now it's for real, right? For all the time we've had wireless in the past, the access point has been the bottleneck. We haven't needed to go above 1 gig because the throughput of the access point couldn't hit that point. Well, today you will see, at least with the Cambium product, we've broken through that barrier, because they also have uplinks that go beyond the single gig. So if you haven't started thinking about 5 gig E or 2.5 gig E as part of your Wi-Fi infrastructure, it's a good time to start thinking about that when you're looking at your Wi-Fi 6. Okay, let's take a look at the lab.
Yeah, there's a couple of quick points on this one, Kevin. The real-world aspect of these tests was very important. There are ways of testing products in the lab where you're using conducted connections to the APs. We wanted to use open air, real clients to emulate real world, and so that was leveraging the labs that we have. The test tools are important. We actually, our Thousand Oaks facility for Cambium, which is where Xeris was from, is right down the street essentially from Keysight. formerly Ixia, which develops the IX Chariot test. And there's actually a number of our folks in our labs who have worked there as well. So testing is kind of ingrained into the fabric of what we do, and improving the performance and the scale of the systems. And so that was very key to establishing a test plan that made sense, that was real world, that delivered some of the results that you're going to see here from that perspective.
Yep, absolutely.
And I'll carry forward onto this slide here. So this is just a couple pictures that we took of the labs here, just to kind of show what we're doing. This is a fisheye lens view, so it's kind of a stretched out. You know, the room is a little more rectangular, obviously, than this, but we have about 400 to 500 devices in this lab, in a basically surrounding the APs, which are there in the center in a tower. And so we can scale this up through automated tests to create very dense scenarios with hundreds of clients connected to an access point, combination of Mac and Windows PCs, tablets, phones, printers, all types of devices, right, from an interoperability, but also a scale perspective. And this ultimately gives you that real world element to the test. The APs in the center there, you scale, you generate the results, and some of the results that you'll see comes from this environment.
Yes, very impressive. Okay, next slide. There we go.
And then this one, was just another view, a Faraday cage, basically where you can get an isolated test, and this is where the drag race test that we talked about was done. You see the laptops on the left, the APs on the right. You basically get the most throughput you possibly can through that, and we emulated the voice and the video traffic in this case with the Chariot application.
Right, and use the Faraday cage to essentially eliminate any of the interference, so you can maximize the throughput. So good.
Right.
Okay, so let's dig into the findings. So a couple of points. Number one, as Riley said, if you have questions as we go along, put those questions in now. We've got a question and answer period coming up later on. And then with respect to my presentation, every image that you'll see here is drawn from the report. And I think, Bruce, is the report available for download later on, or in the
it's in the handouts. In the handout section,
so
yes.
You'll see all that. Okay, this is just a summary. This is our kind of nutshell of the whole thing. And if you look here, you'll see that the first three are related to the 8x8 access point. We got higher throughput and better price performance. The bottom three are related to the 2x2. Here we got good quality performance and, again, price performance. So it's good to look at things two ways. It's a raw performance, but also balancing price into that. So let's push ahead, dig into the first slide here. Okay, so this is the 8x8 throughput test, and as we have mentioned earlier, we'll be doing each one of these first for the 8x8 and then for the 2x2, so they'll look very, very similar. Without delving into every single result here, let me point out a couple of things. You'll see that we have a vertical line here and marked tri-radio and dual mode. So the point here, and I'll give you a little background, and I'll ask Bruce to talk about the Cambium thoughts here, is that with two of the 8x8 devices, the Cambium and the Aruba, there's a way to use software to essentially break up your radio into two radios, so that you have a tri-radio setup across the entire AP compared to the two. And the thing it will point out here is if you just glance at the bars, you can see the bars to the right of that vertical line are lower than to the left. So what we're seeing is fairly good proof and evidence that the tri-radio setup in this max throughput test allows the traffic the aggregate traffic to be significantly greater than when everything's done in just the dual radio. Bruce, a couple of comments from your side on the tri versus dual?
Yeah, I think what we've seen, in the tests in this report, both this one and the high density, is that the tri-radio, spreads the clients out and the spectrum more efficiently when you're running these types of clients and tests. Now that's kind of as we see it today, perhaps with a mixture of Wi-Fi 5 and Wi-Fi 6 clients and the like. The idea with an 8x8 radio, if you run it as one radio, would be if you have higher capability Wi-Fi 6 clients in the future that could take advantage of the 8x8 from that perspective. So there's reason and room for both modes, but in the testing we did and with the current client mix, the tri-radio mode performed better, as you can see here, and ultimately was able to top 2 gigabits total through the access point. So you really are seeing proof of true multi-gigabit Wi-Fi, when you look at these results here.
Sure, and this is our first slide here that points out that the uplink is key, right? If you look at it, it's a little bit hard to see, at least on my screen here, but most of the results are below 1 gigabit, okay? And when you look at having only a single gigabit uplink, those results are always going to stay there because the uplink becomes the bottleneck. With the Cambium product, we have the 5 and the 2.5 gig uplink, so it allows us to remove that bottleneck. And as you can see here, in several of the results, we crash right through that and we push into that realm where we need the uplink. Any other thoughts on uplinks and where that's all going, Bruce?
Yeah, I think that's a key part here. And so where the uplink higher capacity was available, we used it. So we had switches that could run 2.5 or 5, depending on what the access point had. I think it was even more important probably in the 2x2 case, which actually is coming up here, where there was numbers that exceeded the capacity of the uplinks for some of the access points, and that was a kind of a key takeaway from this perspective.
Right. So here we are, same tests run with 2x2. Right. So the raw numbers are going to be different because they're general purpose APs, different technology here. What's important, I think, from the Cambium perspective is we're seeing good solid throughput. And as we called out on the bottom left, where we put the overlay, you can see the link speed. You can see the uplink speed rather. And the uplink speed, certainly in order to get the results that we got for Cambium, we needed that 2.5 gig uplink and we used it, and that's good. The other ones weren't at that level, but couldn't exceed it because the 1 gig uplink would then become the bottleneck. So, I mean, this is something, we do a lot of switch testing. We see from way back to fast Ethernet through where we are today. We just published a 400 gig test the other day. People tend to forget about the kind of these little increments of 2.5 and 5. But it's not because they're not important, but they're important for this market. They're focused really on allowing your AP to take all of that data from all those potential clients out there and not be bottlenecked at that 1 gig. So if you haven't looked at them already, you should look at it. It's a special case type of use, but it's a very important special case. Okay, should we move on to our TCO?
And one quick note here too. I think that if you go back to Wi-Fi 5 or 11AC Wave 2, there was impetus from the market at that point to say, hey, look at your switch infrastructure. You might need to go above a gig. Some of those APs had the higher speed links, but I think that was perhaps premature in many cases. Wi-Fi 6, I think there's definite evidence here that you're pushing the boundaries of the 1 gig barrier with wireless now. So it's much more evident in the Wi-Fi 6 days that you will be hitting those kinds of numbers, and the switch infrastructure is something that has to be considered as part of the upgrade. And certainly with the customers that we're talking to and upgrading to Wi-Fi 6, we are seeing a consideration of the infrastructure much more so than we did in the previous generation. And I think it's evident from just some of the numbers that you see that you don't want to be bottlenecking at that point. So it's a consideration to make for your cabling and your switch infrastructure if necessary.
Absolutely. Couldn't agree more. Okay, so let's take a look. We've looked at some of the kind of the drag race throughput. Now let's take a look at some numbers here. Now we're going to look at numbers 2 different ways. So in the terms of the TCO, we don't have performance bundled into this at all. We're looking at, in this case, list price, and then looking at the basic support and cloud management for 5 years, both again for the 8x8 and for the 2x2. And here, lower is better, right? We want to pay less. We want to pay less and get more. Here, again, just looking at the TCO, we have very significant differences between the $1,300 for the 8x8 with the Cambium on the left and the $665 on the right. In all cases, significantly lower than the competing Aruba, Meraki, and Ruckus products. And this is just for quantity 1, right? When we look at doing APs, we're going to be doing, in most cases, many more than one. So all of this will aggregate as we scale up to whatever number of APs we need for a given deployment. Bruce, comments on TCO from your point of view?
Yeah, so I mean, this is it's a simple TCO, but it provides a baseline for comparison. I mean, obviously, your mileage may vary, discounts, whatever, in terms of what you actually end up, with the street price for it. but I think the important part here was just getting a general view of what the comparison is on the price. Talking about performance and price are both important considerations in terms of determining what what solution you're going to be purchasing from. So we started with this perspective, and it's more than just hardware. You need to consider software and support and all of those things. More sophisticated TCO analysis can be done, and actually we have a tool that does that. We'll talk about towards the end of the session here, where you can get more detailed analysis on that. But this was a consideration for this report that we thought was important to consider, so that you don't not only look at it from just a pure performance perspective, but there's the overall value consideration to make from combining both those components together.
Sure. Yep. And next slide is just really an informational slide. So this I won't dwell on, but the TCO and then the upcoming cost per gigabit used these numbers as the for the calculation. So again, as Bruce said, list prices, depending on who you're buying from and what quantities you're buying, it may vary, but certainly list prices are we've used many times in the past, and certainly a very reasonable way to compare solutions, and including the support and the cloud management. Okay, so let's move on to the next one. So now we're looking at cost, but now we're looking at cost in the context of performance. So we took the bidirectional throughput numbers for each of the tests, the drag race, as we've been calling it, test results that you saw earlier in this presentation, and then took the cost information that we showed on the prior slide and came up with these numbers, which basically says, all things being equal, what am I paying for each megabit of throughput? What's the cost per dollar? Or in terms of the price performance, what am I getting for each dollar that I spend? And here, higher is better, right? We want to get more for less. So we've got the 1.26 for the Cambium, which is significantly higher, more than double any of the other solutions here. So this is really, really useful. We saw already that the Cambium had higher throughput. We saw on the prior slide that Cambium's price was lower. Putting the two together, this gives you a nice empirical way of looking at what is that value in terms of how much am I getting in terms of throughput per dollar that I pay. Bruce, do you have any particular comments on this one?
Or another way to think of it is bang for the buck, another kind of summary of it. But yeah, this is very, again, simple based on the TCO. One thing to consider is a couple of these other solutions have controllers that they oftentimes deploy in larger scale. We didn't even factor that in here. So this was a pretty simple analysis that didn't incorporate some of those other costs. But obviously, it was a very distinctive difference between the two. So I think that was evident of why we included it in the report. So.
Yep, good. And I think if you can make a good case with a simple analysis, that's very, very powerful. Certainly, if you look at more details, usually it gets more complicated and probably more expensive. So, okay. And then we did the same thing with the 2x2. Again, the exact numbers are different because we're looking at different throughput levels, but you can see in terms of the relative cost and the relative bang for the buck, again, the Cambium is very significantly higher, almost twice that of the two nearest competitors of Aruba and Ruckus. So if we look at both of those slides, we're getting the bang for the buck because we're seeing solid performance and we're seeing a very, very competitive price. And put together, it's good news for customers. Bruce, any comments on this one?
Yeah, just one quick note here. The performance of the 2x2 was actually closer across the vendors than the other products were because we didn't have the tri-radio mode. But I think the difference in the price is what ended up making the comparison similar in terms of the orders of magnitude. So just a quick point there.
Sure, and we'll see that too. But, okay, let's move on. So then the kind of the second and final testing group is what we call high density. And you can see if you're staring down at the bottom of the screen to read all those notes, you can see that in the report. But essentially that just summarizes what Bruce and I have been talking about, that it is an environment that has lots of everything. It has Wi-Fi 5, Wi-Fi 6, Windows, Mac OS, laptops, tablets. So that's just to tell you about that. So probably the key things to look at here on the top left and top right. So top left shows us the throughput element of it. So 80% of the clients were there just to basically do the same thing as we did in the drag race test, just to try to move as much data through the AP as possible, while the remaining 20%, again, using the IXIA, Keysight IXIA IX Chariot, we're running simulated voice, where we could get a MOS score, right? So the mean opinion score, which would tell us about voice quality. And what's important there is seeing where that horizontal line is on the upper right chart, because that's the level pretty much where anything above that is good voice quality. So you can see 3 of the 4 are pretty much there, one's significantly lower. So really what you want is to get the best of both worlds. You'd like to see the highest bars on the left, and in terms of voice quality, the highest bars on the right. So we see some good showing there with Cambium at the top of the list on the left, with Aruba just behind it. The other one's much, much lower as far as throughput. And then moving over to the right, we see that 3 of them with a decent voice quality and 1 dropping off. So pretty easy to kind of make your selection there. Just a quick note on the bottom 2 charts, there lower is better, right? There's latency and jitter. We want low latency, we want low jitter. And those 2 things combine essentially into the MOS score. So we can see really where we have with the Ruckus, we have the higher latency and the higher jitter. It gives them the lowest MOS score on the upper right. So we looked at this really, it kind of looking at the, in total, what you're getting for this very, very, hopefully realistic environment. Bruce, other thoughts on this?
Yeah, just a reminder, it was this environment that we did this test in. So this was the high density environment with, in this case, 100 of those laptops that were actually being tested as part of that. And one question that might come up is, why is the throughput here lower than, say, it was in the drag race test? When you add a lot of clients and density, then obviously they're all competing for that same airway and trying to get as much bandwidth as possible. So the overall number ends up going down compared to when you just have a few clients. So that's just one point to make if you're wondering about that. But this is the test that really we focused on to show what kind of numbers you can scale to. We pumped as much possible data through there. There was a lot of background traffic with the video, and then we measured the quality on the voice. It's probably, well, I would say it's almost definitely more stressful than any environment you're probably ever going to run your access points in. But this shows kind of the extreme of what can happen when you do that. 100 is somewhat of an arbitrary number. I mean, these access points will support hundreds and hundreds of client connections, but we wanted to make it, real traffic that's flowing through there for the actual test.
Good, thanks. Okay, and then on the next slide, we have essentially the same test scaled down a little bit with 50 clients on the 2x2. And as Bruce said there, the overall performance, the Cambium and some of the others is a little bit closer than with the 8x8, but as we saw previously, when we factor in the cost, there's still a very, very significant difference. So here again, you read this chart the same way as you read the other charts. Top left, higher is better. Top right, higher is better. Both bottom charts, lower is better. And you can see there's some anomalous performance there with the Aruba AP. And that, of course, is reflected. The higher charts on the bottom give us higher latency and higher jitter, translate into a poorer voice quality and one that would be really degraded to a point where it's unusable. The other vendors do quite well, and both Cambium and Meraki have the top 2 spots as far as throughput goes. Bruce, any other comments on this one?
Yeah, and here I think the 100 and the 50 client numbers were somewhat arbitrary because we wanted to show a high density scenario. And I think what this ultimately shows here, because the quality scores are better, is that we were stressing the 2x2 less with half the clients in this specific case than we were with the other test. But very good results, and I think we're very pleased what we're seeing with 2x2 Wi-Fi 6. It can outperform 4x4 Wi-Fi 5. Based on the kind of numbers that we're seeing, and I think these are very good results overall for that solution. Sure.
Okay. So Bruce, I'm going to let you take the stage here and give us a little bit your thoughts on what does it all mean.
Sure. So all those numbers and charts and everything, we kind of just distilled it down there, into 4 kind of basic buckets of kind of takeaways from this. But I think a few things here that are important. Multi-gigabit Wi-Fi is what we're looking at here. more than several gig of throughput that we can get from a single access point. Your mileage may vary. We've seen some field tests that give even higher numbers than we had here today. 2.5 gig type of numbers. It just depends on the type of test, and there's a lot of variables involved. But I think it's definitely evident with Wi-Fi 6 that we're talking about a multi-gig technology, and that consideration then needs to ripple through in terms of how you're deploying your wired infrastructure to support that. In the 2x2 test, we were able to get a bottleneck on the 1 gig uplinks in some of the tests. So the fact that the Cambium had the 2.5, obviously, we were able to completely, send as much traffic through that access point as possible and not hit that bottleneck in the wired infrastructure. So those considerations are certainly important. The second key takeaway was in the high density tests, and this goes back to the heritage of Xeris with multi-radio access points support high density connectivity. And the more radios you have, the more you can spread out the spectrum across the overall spectrum that's available, especially in 5 gigahertz for wireless, and that results in more performance. So we saw the tri-radio mode in general outperforming the dual radio mode. Cambium and Aruba in this case had that mode, the others didn't, but it's an advantage that is evident by that kind of approach. It's not going to be always necessarily the case, especially as we get more towards pure Wi-Fi 6 environments. Perhaps a dual radio mode would be advantageous, but for now in mixed client environments, I think that ability to spread the clients out and leverage the spectrum certainly provides an advantage. Third point here is when we got into the density tests, we cranked up the traffic and the congestion and the stress on the APs as high as we could with those clients. And it's evident that certainly you can still deliver a quality experience, at least measured by those MOS scores and quality scores, even under congestion. So Wi-Fi is never better positioned, than it ever has been now. It is better positioned than it ever has been to deliver quality of service for voice and video and other kinds of traffic. I mean, we're all doing webinars and video collaboration and Zoom and Teams sessions all the time these days. You need to have rock solid performance. Most of us are connecting over wireless. We don't want the dropouts and the glitches and things like that. Wireless can deliver that quality, and Wi-Fi 6 is positioned to do that better than ever before. We didn't dive into the technology and under the hood, but there's a lot of aspects of Wi-Fi 6 that certainly, enable that quality of experience, reduce the latency, support deterministic applications like voice and video better than before, and support high density scenarios too as well. So, Wi-Fi 6 really is more of a revolutionary comparison to the previous generations than evolutionary. And then finally, the price component of this, the benefits of Wi-Fi 6 does not necessarily mean a premium price for the premium performance, and so that was an important aspect of this test and conclusion. We incorporated that into the comparison, and then calculated a metric that combined both of them. Right, take the total throughput divided by the cost, you kind of get this bang for the buck kind of result that ultimately shows the value that you can really derive from these solutions. And that was an important aspect of this comparison as well. So, good performance at a good price. These solutions can solve a lot of problems, I think, that are evident with, many of our customers that we run into today. They're upgrading their infrastructure. They might have 5-6 year old infrastructure, 11N in some cases. And the difference that you can get from this kind of solution is certainly evident, but you're not going to be paying necessarily a premium price to have to get that. All right. And one more point here. We talked about TCO here, and the solution or the comparison that we made in the report provided a high level kind of simplistic TCO. We have a tool called the TCO Profiler that will provide a much more rich comparison. I just want to mention that here. If you're interested in that, as a Cambium partner, you have access to this tool. As a Cambium customer or prospect, you can request an analysis, and we will basically take a solution and compare the total cost of ownership as well as baseline metrics for performance, and then we add to that all the other elements of consideration. So, the infrastructure cost also includes your switching and your cabling, and then ongoing OpEx over time, power consumption, maintenance costs, things like that, at time of installation, the labor associated with that. So this tool adds all of these in together, and you can compare these same solutions that we talked about today to Cambium in an analysis. So right off the website there is the ability to sign up for analysis if you are interested. And then the output of that is a report, quick example of that right here. So you basically generate a report that can summarize the analysis and gives you a lot of charts and graphs to compare the benefits of the solution and some of the parameters that we kind of talked about relative to some of these other vendors. So just something to be aware of, and something that you can take advantage of there and request some of your own details here when it comes to TCO.
Yeah, we take a look at that too. That's very comprehensive, that's for sure, and it's very well done. I think you've said that you've spent a number of years getting that developed and tweaked and tuned, so it works very, very nicely. And just sit there, fill in some of your information, and you get some very detailed information very quickly. That's good stuff. And so ultimately, the full report is here. This is very, very recent testing. We only published a couple of weeks ago, so everything is fresh, latest hardware, latest firmware. So they're really, really good numbers. So there's a lot more. I mean, you've seen all the core performance charts here, but all the details, some detailed test methodology and other elements you can get in the report. The link is here, and I think Brucey said also it's going to be available in the sidebar here to attendees.
Yeah, the handout section for the webinar, I think there's a little page icon in the console. If you download there, or if you hit that, you can get the report, as well as we included the copy of this presentation as well, and the data sheets for the AP. So just a few things there to download if you're interested.
Okay, great. And that's all I have. Riley, I guess back to you.
All right. Well, actually, we're probably in the position we can take some questions here. All right. So just looking at the questions area here, we got a few coming in. So if you're interested, please pop them into the questions section. Here's one from Paul asking, is the results the same when compared to Cisco? So we have not tested those APs in the lab. That is something that we were looking to do. Sometimes it's a matter of getting hold of product and having the time to run the tests. I would expect similar results, but that's something that we may do in the future as well. I don't know if you have any comment or thoughts on that, Kevin, but obviously we tested 3 vendors. There's others out there as well.
Yeah, I mean, you have to test everyone. You just can't make any assumptions about how one's going to perform.
Yeah. Here's a question about outdoor wireless Wi-Fi 6 from Cambium. So yeah, we're actually close to releasing that product, going into beta next quarter and available mid-year. So contact us if you're looking for more information about our outdoor Wi-Fi 6. And the current products, in fact, you can put into NEMA-rated enclosures that we've spec'd out and tested as well. So we can deploy and have been deploying outdoor scenarios with Wi-Fi 6, leveraging those solutions too. So
hey, Bruce, I have a question.
Another question.
Sure. In your experience, what type of environments are you seeing are benefiting most from Wi-Fi 6 right now?
We've seen a lot. I mean, one of our biggest markets is education, and we're seeing a lot of our educational customers. Their networks are stressed out from heavy-duty use of video and Zoom and Google Meet and these kinds of applications. And so COVID has actually prompted a number of our customers to update infrastructure based on stress points that they're hitting with existing networks from that perspective. So that's definitely one area that we've seen. Enterprises, a lot of folks are still working remote, so there is a lot of home usage as well. Not that we sell these products that we tested here in the home. We do have a residential series of products, but that's another area that's obviously getting impacted by the need for greater wireless connectivity. And then I think the third thing, and again, it's not necessarily related to Wi-Fi 6 specifically, but outdoor wireless, being able to reach greater numbers of people that in some cases may not have internet connectivity. There's been a surge in public Wi-Fi, parking lots, citywide Wi-Fi, places like that, so that people can access the internet beyond their home if they don't have it. I think the number in the U.S. is about 20% of homes do not have Wi-Fi or internet access today. If you look at that internationally, and the number is over 40%. So, we've been selling a lot of solutions just to help to get people access in other areas that they perhaps, did not have internet before, but they need to now because of their remote situation. So,
sure.
All right, another question here. Does the real client mix include Android in this case? In this case, we didn't include Android in the test. We could have. We just, our lab was set up more so with the laptops. We do have a set of tablets and phones and things like that. But in the tests that we have seen, we have done some specific tests for comparing Wi-Fi 5 and Wi-Fi 6 using Android. And in one particular test, we got about twice the performance going from a Wi-Fi 5 to Wi-Fi 6 Android client. I think the number was about 135% performance improvement. So that's definitely something we do more from an interoperability perspective. In this case, we didn't actually have them in these scale tests. All right. And then another question in terms of why was Cambium able to get the better results? I know that if you look at how products are constructed, they're oftentimes based on different silicon from several vendors out there. One thing that we did is in combining and converging the Cambium and the Xeris solutions as part of developing our Wi-Fi 6 product line, we developed a new platform. It wasn't Cambium, it wasn't Xeris. It was actually a new platform based on some of the solutions that were available. And then we didn't really carry forward, in some cases, the same types of legacy code and solutions that were out there. And that allowed us to really architect something that was optimized for performance. And then another point is if you look at just our focus on testing in the labs, we really optimized for performance. That was a key aspect of the design from day one. And I think it's evident in the results that you saw that we were able to achieve those kinds of numbers based on our focus on that as a key aspect of the product. And again, we intend to carry that forward as we develop and release new products. All right. Another question here. Well, related to this webinar, recording will be available. So yeah, absolutely. Riley, maybe you can speak to where that will be posted afterwards so that people can access the recording.
Yeah, so after we finish up today, we'll be sending all of these, all the handout resources and a recording of the webinar individually via email to all attendees. And then we'll also be posting a recording of the webinar on our community page and also our YouTube channel as well.
Okay, great. And another question here related to, is it compatible with Cisco products? I'm not exactly sure what that means, but maybe on the when you're talking about setting up a network of Cambium and working into an environment that may already have Cisco. I mean, absolutely. I mean, these products are compatible in general, and certainly if you're plugging into a Cisco switched infrastructure, that probably happens could be half the time or more, so that certainly is not an issue from the perspective of interoperability. Absolutely. And we can work with products in general. Wi-Fi has a strong interoperability legacy and carries forward into today's technology as well. So, all right. And then I think we're basically reached the end of our questions. So at this point, hand it back over to Riley. Thank you everyone for attending today. Appreciate your time.
Yeah, thank you everyone for joining us today. We're going to stay live here for just a couple minutes to give you the chance to download the handouts, but we'll be sending these out, like I said earlier, in addition to the recording of the webinar to all attendees. But until then, enjoy the rest of your day.
Thanks, everybody.
Thank you. Bye.